Consider this PL formula, not P and Q or not R. There are three atomic formulas, three atoms as we call them, that appear in this larger formula, namely P, Q, and R. Like with any PL formula, if we assign truth values to the atoms in this formula, that will determine a truth value for the formula itself. For example, suppose that P is false, that Q is true, and that R is true. We can calculate what the truth value of the whole formula, not P and Q or not R, is under that assumption about the truth values of its atoms. There are a few different ways to show the steps of the calculation. The standard way to do it is by recording the steps of the calculation in a little table, which we call a truth table. There are two main styles of truth table that you'll see. In one style, you start by creating a column for each atomic formula that appears in the larger formula. So in this case, that's P, Q, and R. Then you create a column for the larger formula itself. In this case, that's not P and Q or not R, way off at the end of the table on the right. We want to know what the truth value of that larger formula is under the assumption that P is false, Q is true, and R is true. So next we enter those truth values for P, Q, and R into the table. Now the larger formula in this case is a disjunction. It's the disjunction of not P and Q and not R. To determine what the truth value of a disjunction is, we need to know the truth value of its disjuncts. So in this case, we need to know the truth value of not P and Q and of not R. So in this style of truth table, we create new columns for those two formulas, with the idea being that we'll first fill in these columns with the truth values for these two formulas, and then we'll use that information to fill in the column for not P and Q or not R, which is our ultimate target. So now we have two formulas whose truth values we want to calculate. Let's start with not R. That's just the negation of R, so all we need to know is what the truth value of R is. We're assuming that R is true. On that assumption, the negation of R is false. Now we can move on to not P and Q. That's the negation of P and Q. So we need to know what the truth value of P and Q is. On this style of creating a truth table, that means that we would create a new column for P and Q, with the idea again being that we'll first fill this column out and then use that information to fill out the column for not P and Q. P and Q is the conjunction of P and Q, so we just need to know the truth values of those atoms to compute the truth value of P and Q. We're assuming that P is false and that Q is true, since by definition both conjuncts have to be true for the whole conjunction to be true. That means that P and Q is false. Now that we've calculated the truth value for P and Q, we can enter the truth value for not P and Q, which must be true. And finally, now that we have computed the truth values for both not P and Q and not R, the disjuncts of our original target formula, we can calculate the truth value of that formula. Since at least one of its disjuncts is true, by definition, that makes the whole disjunction true. So under the assumption that P is false, Q is true, and R is true, the whole formula, not P and Q or not R, would be true. Writing out truth tables in this style is how I learned to do it as a student, but there is another way of doing it that's also popular, and I think actually better. It's more efficient, and it's the style that Smith uses in the textbook. In that style, when you want to calculate the truth value of a formula given a valuation of its atoms, you start in the same way. You create a column for each of the atoms. So in this case, P, Q, and R. You also create a column for the larger formula, but this time it doesn't have to be way off to the right because we're not going to be adding any more columns. We want to know the truth value of this larger formula, assuming that P is false, Q is true, and R is true. So again, we enter those truth values into the table. To calculate the truth value of the larger formula, we have to know the truth value for its first disjunct, not P and Q, and for its second disjunct, not R. But we're not going to create whole new columns for each of those formulas. Instead, we'll just write the truth value for each of those formulas under its main connective. So for not R, its main connective, indeed its only connective, is that negation. So we'll write the truth value for not R underneath that negation sign. Not R is false on this valuation of the atoms P, Q, and R. For not P and Q, its main connective, the connective that's removed first in the process of going down that formula's parse tree, is the negation sign out front. So we would write the truth value for this formula underneath that negation sign. Now, in order to calculate the truth value for not P and Q, we first have to compute the truth value for P and Q, the formula that's being negated. And that formula's main connective is the conjunction sign. So we'll write the truth value for that formula underneath that conjunction sign. On this valuation of the atoms P, Q, and R, P and Q is false. So we can now write down the value true for not P and Q. Now that we have truth values for not P and Q and for not R, we can compute the truth value for the whole original formula and not P and Q or not R. It's true. To record that, we write that truth value down underneath its main connective, which is the disjunction sign that occurs between not P and Q and not R. We also underline it to indicate that it's the truth value of the whole original formula on the given valuation of its atoms.